Hello class, we are still working on functions. Today's essential question is, how do I evaluate functions? Learning intention. I know I'm successful when I can evaluate any function. So you've got two warm-up questions. So pause the video and see if you can identify whether they are functions or not, and then find the domain and range. Pause the video now, please. Well, I do hope you tried to do them on your own. So as you're looking at this, we're looking at our x values. I've got 3, -5, -4, 7, 8, and 1. None of the numbers, none of the inputs repeat. So this means it is a function. My domain. Okay, the smallest number is -5. -4, -3, 1, 3, 7, and 8. Oh boy, that barely fit, didn't it? Okay, so that was the domain. What about the range? The range is all the numbers that are the output, that are the y values. So this would be 4, 6, -1, -3, 8, 9. So -1. Nope, -3, -1. Okay, -3, -1, 4, 6, 8, and 9. So that's the domain and range. It is a function because your inputs do not change. For the next one, is it a function? No. Does not pass the vertical line test. Okay, it's not a function because it does not pass the vertical line test. Now for the domain, this time we have to write it in interval notation. Remember, if it is parentheses, that means it does not touch that point. If it's a bracket, it does. So for our domain, we start at -2 with open circles. That means this is -2. And we go up to +2, but it is a closed circle. That's your bracket. What about the range? Well, if you notice, the range starts at -1 with an open circle, and it goes up to +3 with another open circle. And that's the domain and range written in interval notation. Okay, evaluating functions. I want you to take a minute and look. This is f of x. The expression you use is 2x minus 6. F of 3, what does that tell you? Think about it logically. What do you notice? If you said x and 3 are in the same position, that x must be equal to 3, you would be right. So this is 2 times 3 minus 6. 6 minus 6, and you end up with 0. So my function f, when I evaluate it with 3, I get 0. In this case, x is equal to -7. 2 times negative 7 minus 6. I'm substituting negative 7 in for x now. 2 times negative 7 is negative 14, minus 6 more is equal to negative 20. So when I take my function f and I put negative 7 in for x, my answer is negative 20. Okay, so we've got all of these different equations. This tells you which equation to use. This tells you which x value you are going to want to use. So I'm looking for my equation q. This is q. My function q evaluated at x is equal to the opposite of x plus 8. Okay, but I'm starting with a positive 4. What is the opposite of 4? Negative 4 plus 8, and I get 4. So when I take my function q and I put 4 in for x, the output is also 4. Okay, my function k, I look up here. There's k. K, when I evaluate it with x, I use the expression, the opposite of x squared plus 2. Okay, I'm going to put negative 3 in for k. So this is the opposite of negative 3 squared plus 2. Negative 3 squared is 9. The opposite of 9 is negative 9 plus 2, and I end up with negative 7. So when I take my function k and in place of x I put negative 3, my output is negative 7. Okay, we're looking for f now. F is the first one. F evaluated with x is 3x plus 8. But I know my x value is negative 6. So this is equal to 3 times negative 6 plus 8. 3 times negative 6 is negative 18 plus 8, which gives me negative 10. So when I take my function f and I put negative 6 in for x, my output is negative 10. Can you do the next one on your own, or are you still struggling with the idea? If you think you can, go ahead and pause the video and try the next one on your own. Well, if you didn't, that's fine too. We'll go through n. N evaluated at x is the opposite of x. What is the opposite of 6? Negative 6, and we're done. What about j? Can you do j evaluated with negative 7 on your own? J evaluated with negative 7 is j of x is negative 7x plus 1. What is our j value? Negative 7. Negative 7 times negative 7 plus 1 is 49 plus 1, which is 50. Negative times negative is a positive. 7 times 7 is 49. So j, when I put negative 7 in for x, I end up with the number 50. Can you do the next one on your own? What is g? G of x is the opposite of x plus 6. Can you do g of 0? I hope you tried. So g of x, I find the opposite of x plus 6. So g of 0 is the opposite of 0, which 0 doesn't have an opposite, plus 6, which gives me 6. So when I take my function g and I put in 0, my output is positive 6. What about my function h evaluated at 10? If you have not tried one yet, now's the time. Pause the video, try. Well, I do hope you tried. H evaluated at x is simply x squared. So h evaluated at 10 is 10 squared, which gives me 100. So h, when I put 10 in for x, my output is 100. Okay, I didn't get one in for p. I probably did, and then when I did some deleting, I probably deleted it. So we're going to put p of negative 1 is equal to. I come up to p. P evaluated at x is x squared minus 4. So this will be negative 1 squared minus 4. Negative 1 times negative 1 is 1. Minus 4 is negative 3. So when I take my function p and negative 1 is my input, my output is negative 3. Okay, so that shows you with an equation how you input, how you evaluate the function. What happens though if you have a graph? As I'm looking at the first one, where is x equal to 0 at? It's equal to 0 on the y-axis. Where does my graph start? It starts at 0, 0. This graph is actually the square root of x. So when z is 1, what is my output? When z is 1, my output y is 1. What about when z is 4? My output is 2. So that's how you use a graph. How do you know you're successful? You know you're successful when you can evaluate any function. Today we are evaluating functions.